Hey guys, we're on Unit 8, and this is day 1, and we're going to simplify, add, and subtract radicals today. In our warm-up, we are given point A, which is at -3, 2, and we have a composition of transformations. And in this one, we have to make sure that we do the rotation of 90 degrees around the origin first. So if we plot -3, +2, we end up right here. Okay. The right way to turn your paper is to the right, and for 90 degrees, we will turn it once to the right. Once our paper is rotated and we replot -3, +2, this is where A prime is going to be. And then we turn our paper back. You can see that it rotated 90 degrees counterclockwise, which is what it's supposed to do. And so now our point is at -2, -3. All right. Now we have to go ahead and do the reflection over the y-axis. And we can see that our point is 2 units away from the y-axis, so 2 units on the other side. We'll put our A double prime in its final spot, and the coordinates of our point become +2, -3. And so this is our final answer. Okay. All right, in order to simplify a radical, we need to find the largest perfect square, okay? That is a factor that goes in with division, all right? Once we find the largest perfect square, we're going to take the square root of it, and we're going to place that value outside the radical. The factor that is not a perfect square remains inside the radical or under the radical. All right, so in order to do that process, we have to know our perfect squares. And our perfect squares come from taking an integer and squaring it or multiplying it by itself. And so 1 is our number, and we multiply it by 1. That's the same thing as 1 squared, which is 1. Okay? If we take 2 and we multiply by itself, we get 4. 4 is our perfect square. Okay? 3 times 3, or 3 squared, is 9. 4 times 4, or 4 squared, is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. And 13 squared is 169. And they keep going forever and ever. But usually that's a good amount of perfect squares to figure out our largest. All right. It's not the full list, but it should be a list that is good enough. All right. So that's always our first step, to have those numbers in front of us. And now we'll go ahead and say, all right, square root of 50. Notice it's not on our perfect square list. When we take the square root of 50, we get an ugly decimal called an irrational number. And we want to simplify it. So we don't want to evaluate it. We don't want to stick it in our calculator and get a decimal form for it. Instead, what we want to do is we want to break it up into 2 different perfect squares. All right. So 50 can be made up of 5 and 10, okay? Or 2 and 25, or 1 and 50, but we want the largest perfect square that goes into 50. So usually what we do is we go and find where 50 would fall, and we go down the list, because remember what they said, they want the largest perfect square. 50 divided by 49 doesn't go in. 50 divided by 36 doesn't go in, but 50 divided by 25 does. And so because 25 is our perfect number, it goes in the first house, or the first radical. 25 times 2 is going to give us that 50. So they say the square root of 25 times the square root of 2 is the square root of 50. Because this is perfect, I usually circle it because it equals something else. The square root of 25, and you can go back to the list here, is 5. And so we'll put the 5 right underneath it. Okay. Not the square root of 5, just 5. Square root of 25 is just 5, okay? And then the square root of 2 is what we call the non-perfect, and so that stays. And there it is. If we put 5 square root of 2 in our calculator, it gives us the same decimal as if we put the square root of 50 in our calculator. It's just that 5 square root of 2 is what they call simplest radical form. All right, so let's try the next one. You see there's a 3 out in front. What happens to that 3 is that it stays until the end. We won't use it until the end. But the square root of 32, you can see that it's not on our list of perfect squares, and so we're going to have to find the largest perfect that goes into it. So what we do is we come back up here and we look for where 32 would fall. It would fall in between here, 25 and 36. And so we go down the list in order to find the largest perfect square. 32 divided by 25 won't go in evenly. However, 32 divided by 16 will. So 16 is the perfect square, the largest perfect square. And then 16 times 2 is that 32. So now we go back and we circle the perfect and we bring it down. Square root of 16 is 4. Everything else just comes down. All right, and then we got an issue out in front. We have 3 and 4 next to each other, but with no operation in between them, so we take that as multiplication. All right, and then 3 times 4 is 12, square root of 2, and that is a simplest radical form, okay? If you type it in your calculator, it should give you the same decimal as 3 square root of 32 typed in your calculator. All right, let's try the next one. Again, the 1/2 won't be used until the end. And the square root of 12, you can see that 12 is not on our perfect square list. So we're going to go ahead and break it up into the largest perfect square that is on our list. All right, and so if you figure out where 12 falls in the perfect squares and we go down the list, 12 divided by 9 doesn't go in evenly, but 12 divided by 4 does. So 4 is the perfect square from our list, and 3 would be the other number or the not perfect square. Okay, and we circle the square root of 4. Because that equals 2. And that's why we always have to have a perfect square in that first radical, all right, so that we can do that second step process where we take the square root of it and it gives us a nice number. Everything else just comes down. And when that 1/2 comes down, remember there's multiplication in between there. So 1/2 times 2 or half of 2 is 1, and we end up with 1 square root of 3. However, 1 square root of 3 can also be written as just the square root of 3. They don't need the 1 out in front. Okay. And our next one, the square root of 36, you notice that it is on our list. So we're going to circle it. It's already perfect. And so we can go ahead and just arrow down and say that the square root of 36 is 6. Okay, so that was an easy one. We had to recognize that that was a perfect square. And we'll try the next set. Next up, we have 6 square root of 48. You'll notice 48 isn't on our perfect square list, so we're going to find the largest perfect square that does go into 48 that is on our list. So 6 stays, and we break it up into 2 radicals. Okay? If you take a look up where 48 falls and go down the list to see the largest perfect square, you're going to find that 16 is the first number that goes in. 16 times 3 is 48. We'll go ahead and circle our perfect. Square root of 16 is 4. Everything else just comes down. We put multiplication in between. 6 times 4 is 24. Square root of 3. And there's our simplified radical. All right, next one up. 54 is not a perfect square. So we're going to find the perfect square that goes into it. Remember, you want the largest perfect square. So find 54. And going down the list, you're going to find that 9 is the first perfect square that goes into 54. And it goes in 6 times. We'll go back and we'll circle the square root of 9. Square root of 9 is 3. Everything else just comes down. And put the multiplication between the 2/3 and the 3. 2/3 of 3 is 2. Square root of 6. All right, number 7. You're going to notice the square root of 80 is not a perfect square. So we're going to find the largest perfect square that goes into 80. So find it on your list and go down the list. And you're going to find that it's 16. The other number is 5. Circle the perfect. It becomes a 4. Square root of 5 comes down. Negative 3 comes down. Multiplication goes in between. And you end up with negative 12 square root of 5. All All right. Remember, guys, you always want to find the largest perfect square, because if you don't, then it's not in simplest form. It'll be simpler, just not simplest. Okay. Remember that if directions say simplest form, you have to find that largest perfect square. All right. 175 is not a perfect square. So going down the list, okay, it might take you a while to figure out what it is, but it's 25. And 25 goes into 175 7 times. We go back, we circle our perfect. We simplify that to 5. Square root of 7 comes down, the 4 comes down, multiplication goes in between, and we end up with 20 square root of 7. And that's how we simplify radicals. All right, I will see you guys on the back side of notes.